It's also a good way to keep you all quiet. Because I could say, listen to this. You hear you kids, and that's why you expect them to. Okay, so I Googled similar triangles, and this was the first thing that came up, right? It was kind of looked at animation and everything. So the triangles are similar if they have the same shape, but can be different sizes. Well, actually, I think they are different sizes, otherwise they're congruent, right? They are still similar even if one is rotated or one is a mirror image of the other. Try this. Drag any orange dot. So I thought this was kind of cool. Right, so I could pick up an orange dot and kind of drag that, and the triangles will remain similar. And let me get a nice number. Oops. So this is 20. What's the corresponding side? 10. So this is 8.5, and the corresponding side is? 17. What's the relationship between these two similar triangles? This one is twice as big as this one, right? So we know that which angle corresponds to angle P? Prime. Good. Oh, I thought I'd have to tell you all that. You knew that. It's cool. So P prime, that's a prime. We pronounce it prime, right? Because I don't know, saying P apostrophe would just be. Yeah. So it's called P prime, right? That's Q prime and that's R prime. And they're marked on there as a little arc to show I'm measuring an angle, and then this angle here is not the same as this angle here, right? It's different. And what's kind of neat here is too is that, oops. And what angle is that angle? A right angle. Right? How do you know? Yeah, it's a little box there, right? And that shows, that denotes a right angle, right? This still corresponding angles. We're still in a ratio of 2 to 1, right? If I move this one out here, so 13 and 26 and so on, right? It's all okay. Kind of cool. And then it goes on to give us some more stuff. Triangles are similar if they have the same shape, but not necessarily the same size, right? This is not saying anything you don't already know, right? Because this is review. You can think of it as zooming in or making a triangle bigger or smaller, but keeping its basic shape. In the figure, I don't need to read that to you. If you want to look at it, right, I mean, you can either find the page, well, you won't, while you find the page, it was the first hit in Google, but you can also pause the video and then just read this yourself, right? So, but important stuff, look, the prime. You'll read that beforehand. So, corresponding angles are congruent. They are the same, okay? So corresponding angles are the same. Corresponding sides are in the same proportion, right? So that PQ is to P prime Q prime as QR is, so if this is 2 over 1, that's 2 over 1, that's 2 over 1, right? If you reduced it, right? So 17 over 8.5 would be the same as, so they're all in the same proportion. And it goes on to rotation. So these are similar triangles even though they're rotated, right? One is rotated, it's in a different orientation. We still need to recognize that, hey, well, okay, here's the right angle, and this side is a smaller side, and that's 9, and this is 6. So what's the proportionality? 9 over 6, 3 over 2. You gotta work on your fractions. Okay? It's easier to work with the 9 and the 6, right? It won't be so easy to work with like the 16.5, which actually doesn't correspond to that 16.5, but to the 18, or no, those do correspond. Reflection. Oh wait, that's not a 9. These are the same size. Never mind. So, moral of the story is look through the stuff before you give it. I thought it was a 6. It's not. It's a 9. Why don't you point that out? You're looking at it upside down. It's a 9. Those are actually congruent triangles, right? Look. They're also congruent. Read the stuff. So that, yes, the whole year is going to go like this. So just so you know. Rotation, you can rotate them. Okay, these are different sizes. That's a 6, that's a 12, that's twice as big. How to tell if triangles are similar, right? So how do you tell? Triangles defined by 6 measures, 3 sides, 3 angles, but you don't need to know all of them to show they're similar. Various groups of 3 will do. Triangles are similar if you have angle, angle, angle. All 3 angles are the same, right? If you have side, side, side in the same proportion, so not side, side, side is the same as the other sides, that's a triangle congruency, right? If the 3 sides are exactly the same, but that they're in the same proportion. Or you have side, angle, side. 2 pairs of sides in the same proportion with the included angle being equal. Similar triangles can have shared parts. So in other words, we could take this triangle and split it like this. So this triangle here is similar to the whole triangle. Picked up. And then there's some related topics and stuff, right? So that's where you can start out on anything, right? Just looking to say, well, okay, what do I know about similar triangles? I forget, so you go look up some stuff and read it and take a look. And then that allows us to move into this, which puts the scroll bar over here. Key ideas reviewed. Notice where this is from, right? Math links. It's last year. Key ideas review. Choose from the following terms to complete 1 and 2. So those are the numbers we're going to put in. So corresponding blank are equal in measure. Angles, right? Because not just doesn't fit. Corresponding angles are equal in measure. Can you all read cursive?
Yeah.
Because we're getting to the point where kids can't, like younger kids don't learn how to, can you all write that way too? I mean, you might choose not to, but did you learn to? Yeah? No? See? Must depend what school you went to. So there's a whole thing on should you know it or not, and there's all this, well, brain development and stuff, like that's a higher motor function to do that than it is to print, but then we don't much print, right? I mean, we text and we type but whatever. You feel free to print. I'm going to feel free to write and print. Corresponding blank are proportional in length. Sides. Look at that. These guys are stars. Look, I'll print this one. Okay, I'm going to half print half. Usually it's a hybrid, right? Whatever. You can solve problems for similar triangle using a blank or a blank. Using a scale factor or a scale factor. It's supposed to say proportion. I don't usually write much. It's kind of a hybrid stuff. Proportion. But I'll say it and you can watch the video back again. What was that word you wrote there? I can't even read this. Is triangle DEF similar to ABC?
Yes.
Yes. Okay. Explain.
They're the same angles and proportional lines.
So, yes. So corresponding angles are equal. And what else did you say?
The sides are proportional.
Corresponding sides are proportional. Is. At any point when I make mistakes, not yet, stop me and just say something about it. Or if you have a question at any time, stop and ask about it, right? Is triangle DEF similar to triangle PQR? No. Why not?
Like the opposite of what we just wrote.
Can we say anything about the angles?
Well, a right angle. One of them is a right angle.
Is it a right angle? What makes the right angle a right? What denotes a right angle?
90 degrees.
Do you see a 90 degrees written on there?
No.
Okay, what else denotes a right angle? Square, box. Do you see a square or box on there? Then you don't know anything about that angle, right? You could say, it doesn't look like any of the other angles, right? But you can't really make a statement about this triangle and this triangle based on angles because you have no information on that.
You say like they're different shapes.
But you can say, hey, I got 3 sides, and those sides are not proportional, right? What kind of triangle is this?
Equilateral. No. Isosceles.
Spell isosceles. What kind of triangle is this?
Scalene.
Scalene. Good. So obviously an equilateral, obviously an isosceles triangle, which is not equilateral, but it's 2/3 of the way there, is not proportional to a scalene triangle, right? It can't be. So sides are, what we can say here is the sides are not proportional because we are given the sides, right? So you cannot, you know, so you ever watch the lawyer show, you're assuming facts not in evidence. Oh, the angles are, no. Right? Yes, it looks like a right angle. Maybe it is. Maybe it's 91 degrees, right? You got no way to know that. Okay. If that angle were labeled as 90, good enough, right? You could say corresponding angles aren't equal. There is no angle that corresponds to that angle, right? You could be pretty darn sure that there's no angle that corresponds to that angle, but you can't use angles in your argument because it's not labeled, okay? Right? Picky, but math is picky, right? You have, it's in the details. So sides are not proportional. And if you wanted to, you could go on to say one triangle is equilateral, the other triangle is scalene. Isosceles. You could say one triangle is equilateral, you'd be wrong. Check your understanding. What are the corresponding angles of the corresponding sides for the following pairs of similar triangles? How do we know they're similar? Because they said so. As it said, the following pairs of similar triangles. So they're telling us these triangles are similar. So what are the corresponding, what do you want to start with, angles or sides?
Sides.
Sides. Okay, what are the corresponding sides? AB, let me start you out. AB and JK. So, are you serious about that, or? Okay, BC and? And what do we want to call the third side? AC and? JL. You get too many answers wrong, you will end up in JL. Corresponding angles. Okay. This is the symbol for angle, right? Angle B and angle K and angle C and angle L. Okay, you do B. So PQ and MN, QR and PR and okay, so I said PR, you say? Oh wait. So where is it? QR, oh you said N.
Yeah.
Correct me if I'm wrong. I listen to you guys far too much. So PR and ML. Angle P and where's M? P, angle M, angle Q and angle R and okay, any questions on what appears to be the first page? Front side? No? Pretty good? If at any point you have any questions, please ask. So, moving on. Determine. We actually have a specific meaning to the word determine in math. You will not see it on your diploma exam. The specific meaning to the word determine, which you will see on your tests throughout grades 10, 11, and 12. Word determine means, I'm going to hazard a guess. I'll say, show your work. Okay? So if you see the, and we sometimes misuse it, we put in determine when it really should say state. So if we say state, what do you think you should do?
Just write the answer.
Just write the answer down, right? State is just give me the answer, I don't care how you worked it out, right? Like, you know, state the answer to 2 plus 2. I don't care how you got that. 4. But if I say determine x when x squared equals 117 or something, and I'm asking you to show me some work, right? Show me the work that leads to the answer. Anyway, so sometimes the word determine will be misused. This could be one of those times. But Determine which pair of triangles is similar. Explain how you know. Okay, so this has nothing to do with the diagram to the right, in case you're looking, because I was looking. What? So this is just in this table. Determine which pair of triangles. So, what do you got? Could it be P, Q, R, and STU? No. Could it be STU and VWX? No. Could it be PQR and VWX? Okay. So if it is, then are they? Yes. Okay, how do you know? Yeah?
I was doing this last night, and when I was seeing if the sides are proportional with the numbers that didn't add up.
Numbers didn't add up, so it's possible then. So I kind of want.
Did it wrong? I don't know.
Well, how would we figure out if they're proportional?
I just divided it.
Okay, so we do 11.3 divided by 3, right?
Yeah.
Okay, so what's 11.3 divided by 3? 2.9. Okay, then what should 16 divided by 4.2 be? Is it?
No.
Then they're not proportional. Or is it? And you just got it wrong. Maybe it is. What's 16 divided by 4.2? 2.8? 3.7?
Yeah.
Whatever. Not.
And
So I guess they're determine which pair. Yeah, almost implies that they are, right?
Yeah.
Determine which pair is similar. Explain how you know. All right, let me look at the answer that's written down on my answer key.
But how would you show your work to it? Or you just copy?
VWX and PQR. Well, let me read the answer that's here because it's kind of interesting. V says triangle VWX. So, I mean, what I might be tempted to do here is say, okay, the P, which is 90, corresponds to the W. So let's write W there. And then PQ is 3 and WX is 11.3. That kind of corresponds. So let's say we put an X there and then the V would go there. So that QR would have to correspond to XV. So QR corresponds to XV or VX. Or sort of get an idea as to whether they are. All right, on here it says, triangle VWX, triangle PQR, both are isosceles right triangles with 45-degree acute angles. Corresponding sides are proportional. Yeah, no, they're not. Okay, so basically say, well, the only pair that could be, what I would examine is this pair, right? Because this is out. Okay, these have the angles correct, but the sides are not proportional, right? Because this is 2.9 times larger than that, right? Unless somebody messed up the calculation, and this is not. So there is no proportion. It's like a lousy question, right? And yet it implies, right? It says which pair is similar. It's how do you know? Well, we know that whoever wrote this didn't have anybody check their stuff over well. All right, let's do B. Determine which pair of triangles is similar.
well, that's for question 7.
Oh, is it?
Yeah.
Oh. Look at the whole thing. Never mind. Okay. 6. Oh, it goes down. You gotta look at the big picture. Are these triangles similar? Explain how you know. Are they similar?
Yeah.
So if they're similar, then this side over this side has to be equal to this side over this side. Has to be equal to this side over this side. Is this a true statement? Of course, neither were these up here either, right? For the reasons as discussed. Okay, we didn't write a whole bunch of stuff down. I'm going to move my frame. Determine the missing side lengths of the triangles below. Show your calculation. God, he writes sloppy stuff in grade 9, eh? Like, really? What does this need? What should this really say? It's missing something. Determine the missing side lengths of the similar triangles. Well, we know they're similar. I didn't say they were similar. Got to say that, right? I mean, how do you know? If you don't know they're similar, and how do you determine the side? There's just two triangles. So what? Right? Who cares? God. We're going to have to retrain you all. It's not your fault, but obviously the materials you've been working with are pretty inferior stuff, right? So pay attention to me. I will not steer you wrong, but when I say do stuff, you got to do stuff. Right? We'll get you through this. Okay. Now, so I've thrown in the word similar, so show your calculations. So what are you going to do? Yep.
Use proportions or ratios and then cos multiply sides.
Sure. Okay, so we're going to say, well, these two sides need to be in a proportion, right? Which is like times 3, right? And that times 3, right? Obviously I'm going the wrong way. Okay, so what do we got to do that? No, actually I'm going the right way. And what do you got? 21 and done. Okay. Doesn't that work? Kind of works for me, but it's not really very mathematical, right? It's more of an intuitive thing. It's like I looked at it and I said, hey, look, you know, just multiply by 3, multiply by 3. If I want to show this mathematically, then I need to really say something like, well, okay, so 25.2 over 8.4 is equal to x over 7. Right? So I'm showing that since I know they are similar triangles, right, because I threw the word similar in there to make the question actually doable. Since I know they're similar triangles, and I know the sides are in proportions, and that this proportion must hold. So what's x equal to?
21.
So 7 times 25.2 over 8.4, which is 21. Okay, that's a little sloppy. Don't write that. Extend the page, go down here, write it on a separate line. X equals 21. Okay? It's better to keep, you know, because this flows, right? Otherwise, you write equals 21 there, and it's like, I got to flow along. So really only want to see one equal sign on a line, right? So you don't go, this is equal to this, is equal to this, equal to this, equal to this. Now work your way down. Okay? Okay, now, 7b. Okay, what was the question? Oh, determine the missing side lengths of the similar triangles below. So now we are now told these are similar triangles. And so what? What do you want? That's the answer. You got to work. It says determine. What does the word determine mean? Show your work. Good. See, we've learned something already. So what are we going to show? Pick easy numbers this time. 20 over 10 is equal to x over 6.9. So, what's x equal to? There you go. Any questions? It's been a while since I've taught grade 10, so you might want to just say, what are you doing there, right? Like sometimes I don't necessarily show all I should show. Draw a triangle that is similar to that. Okay, we're not going to do that one, right? So we need a protractor and a ruler, and that, but you could do that, right? Just all I would do is kind of measure this and then draw something like twice as big as that. And then measure this angle and then draw that angle and draw something that's twice as big as that. And then just fill in the third side because obviously it has to be, you know. Okay? All you do, you don't have a ruler or protractor. You need tools. Kaylee is 100 centimeters tall and is standing so that her mother's shadow covers her shadow. She is 90 centimeters from her mother, and her mother's shadow is 225 centimeters long. How tall is her mother? Express your answer to the nearest centimeter. So here we have what we saw on the, when I did the similar, it's similar triangles, but one triangle within another triangle, right? That type of similarity, as opposed to like two distinct triangles. Now here's two distinct triangles, we figured it all out. So what are we going to call this? Let's put a letter on it. X. Okay, what am I going to write? Do we need to know this?
Yeah.
Okay, what is it?
135 centimeters.
Because it's right here.
Okay, everybody know how we got that?
Yeah.
Okay, good. Again, if you don't understand something, you just ask, right? Did I pass around an attendance list? No. Okay, I'm going to pass this around, just put a check next to your name. If you're wondering why there's an asterisk there, it's just they're new, and so that I know that they weren't here yesterday because they weren't in the class yesterday. There's two asterisks there, then it just means it happened twice. Anyway, find your name, put a check mark next to it. If you're not on the list, then write your name at the bottom, okay? And then I'll just go, oh my God, more? Like it's that one. It's like, there's 42 desks in here. Actually, I think everybody's here because there's 42 desks in here and I only see one empty one, so whatever. Welcome to education in the, thank the Tory government for that, right? Thank funding. Thank the CBE for, oh wait, this is recording. Never mind. Okay, onwards, I could pause. And yes, call your MLA. So, yeah, call your MLA. Okay, what do we write? What's our proportion we want to write? So let's start with the unknown. X over. Okay, so we're going to work in the big triangle, right? So we're saying this triangle here is similar to this triangle here, right? They both have 90s. These angles are both, this angle is the same because it's in both triangles, right? It's part of the big triangle and the little triangle. Therefore, this angle has to be the same by the triangle sum theory. They have to add up to 180, right? And blah, blah, blah. Okay, equals what? Yeah. All right, so you're going to want a triangle. I'm just going to say it's 133.3, right? Repeating. Is it? I could say that, but I could be wrong. No, that's wrong. Hang on, it's 5. It's 260 something. What is it? Okay, what's the answer? Nearest centimeter. To the nearest centimeter, what is it?
166.66 repeating.
So
67.
67.
Okay, 167 centimeters. Good. Everybody good with this? Yeah. 2 thumbs up. All right.
Reading at the center.
God, no. So, wait, let me right triangles and the Pythagorean Theorem. A right triangle is a triangle that contains an angle that...
I don't have that. We got that right triangle. We got the similar triangle.
All right triangles and Pythagorean Theorem. Take 2. A right triangle contains an angle that measures 90. Look, we gave you the degree symbol. The measure of the other two angles of the triangle are less than 90, and therefore are called acute. Angles. Okay, so angles less than 90 are acute angles. The measures of all 3 interior angles of any triangle add up to 180 degrees. That's called the triangle sum theorem. You don't need to know that, but I mean, you need to know that they add up to 180. You don't need to know that it's called the. Since one of the angles in a right triangle has a measure of 90 degrees, this means the measures of the two acute angles add up to 90. State, which means what? Just write the answer down. You don't need to show any work. State the measure of the unknown angles. I suppose it could be unknown, well, in this case, each one. So what's this angle?
62.
62. Because we know these two angles have to add up to? 90. And what's this angle?
27.
Because we know these two angles have to add up to? 90. Yeah. That was pretty quick, huh? Oh, wait, but it's only the first part. Lengths of sides. The side of the right triangle that is opposite the right angle is called the, right? Because I wore the shirt yesterday, right? You spell it a little bit differently, but this is the Wisewood Math shirt. Right? So it's supposed to say pie, right? Not just for dessert. I wonder what the plural of hypotenuse is. The two sides of the right triangle that form the right angles are called the legs. Label the sides of the right triangle shown. So what's this side? Hypotenuse. What's this side?
Leg.
A leg. And we'll call it leg sub 1. So sub as in subscript, as in written below, you know, submarine, below. As opposed to up, if I put it up, that would be?
Superscript.
Superscript. See, because we wouldn't have known that before we got into all this font stuff, right? Okay, and this is leg 2, sub 2. Okay, so just to distinguish the two legs. The three sides of any right triangle are related to each other. This relationship is called Pythagorean Theorem. Who's it named after?
Pythagoras.
Was he probably the first guy to develop it? Probably not.
It's the famous.
Yeah. You got to claim, oh, Pythagorean, wait, we need the word theorem. Which states that leg sub 1 squared plus leg sub 2 squared equals the square of the hypotenuse, right? Hypotenuse squared. Do you know where that comes from? Like, why is that what it is? Have you seen, hang on, pause. So, look at that. So years ago, a man named Pythagoras, or Pythagoras, I'm not really sure how it's pronounced, but found an amazing fact about triangles. Triangle, right triangle, and you made a square on each of the three sides. Yeah, right angle. Make a square on that side, square on that, square on that side. And if you take those two squares, so that the sum of the square of the hypotenuse, right? The biggest square had the exact same area as the other two squares put together. It's called Pythagoras' theorem. We go with Pythagorean theorem. And it can be written in one short equation, a squared plus b squared equals c squared, right? Which is a lot easier to write than leg 1 squared plus leg 2 squared equals hypotenuse squared. And then there's some other stuff here. How to use it. Okay, back to the notebook, which was this notebook. Okay, determine, which means show your work. The length of the unknown side rounded to the nearest tenth. All right, so we got some room here. So, what are we going to write?
7.2 plus 5
So we're going to write x squared is equal to what?
Do you have to square them?
You tell me. What's x squared equal to?
A squared plus b squared equals c squared.
Okay, which is?
Or leg squared plus leg 1 squared plus leg 2 squared.
Okay, what's leg 1?
Oh,
Oh, that's what you want. Okay, yeah. Okay, what do I write now? Gets easier now, right? Plus. Okay, we don't put the units in, right? I only say that because I saw Melchuk doing it earlier, emphasizing we don't put the units in. It's not science. Okay, it's math. In science, you do put units in and stuff. You do what your science teacher tells you in science. You do what your math teacher tells you in math. So in math, we don't put the units in, right? We're at x squared is equal to 7.2 squared plus 5.6 squared, which is equal to
52.2. But then you
52.2 plus, or yeah, 50, that seems reasonable for 7.2 squared. What's 5.6 squared?
No, that's all of it together.
Oh, that's all of it together?
Yeah, but
Really? Like, that's 49 and that's 25, so.
I got 83.2.
Okay. So 83.2. All right, is that an acceptable amount of work? Did I need to show the 7.2 actually squared? Probably not. Okay, we'll go with that, right? Okay, now what do I write?
X equals the square root
Of 83.2.
Right, so this is what we call an exact value. Okay? The square root of 83.2 is an exact value. Okay? Now, we don't want an exact value as the answer, but it's a step on the road to the answer. So we're going to show that, right? We're going to show x squared is equal to, and then we're going to show that it's the sum of these two squared. We're then going to say x squared is equal to, and we're going to give that sum. If you want to write one other line where you actually write what 7.2 squared is, well, that's fine. Okay. Then we're going to say x is equal to the square root of that. That's an exact value. And sometimes in math, that's what we're going for, is that exact value. And now we're going to give the answer written to the nearest tenth, which is 9.1. And at this point, we are now going to bring the units back. So 9.1 what? Millimeters. So the final answer has the units. But that's the only place you see the units, right? So the units are on the diagram, not in any of the calculations. When we state the final answer, which we determined by showing the work, right? But when we're stating the final answer, that's when we put on the units. If you leave units off, we leave half marks off. Okay. So, well, sorry, no, half off. And and if I'm nice about it, I'll do it every single time that you do it. And then on the final exam, we might only do it like for 1 mark in total, but probably early on, I'm just going to hit you every time, right? Because if I pound you over the head often enough, then you'll come to, oh my God, I lost like 3.5 marks on that test because I didn't write a single unit in. You're going to start writing in units, right? So, or not. You just might be a slow learner. Never really learned to write the units in. Okay, what do we do for the next one?
X squared equals 13.1 squared plus 8.
Minus.
Just kidding.
Okay, so I'm not going to use x because I don't see x in there.
Or A.
A. Okay. So what I might want to write is this. So the Pythagorean theorem says a squared plus b squared equals c squared, right? So I'm actually going to write it out in that form. Now we can do a little bit of rearrangement. Say, but a squared is equal to 13.1 squared minus 8.2 squared. So a squared is equal to, you want to give me the final number?
104.4.
All right, sounds good. Wait, that's double the last answer you gave me, which was wrong. So why should I trust you? You're just doubling up answers.
Someone else can do it.
Yeah, I want independent verification.
10.6.
That's the final answer.
Yeah.
Okay, was it 104.4? That was really coincidental, right? That you get the wrong answer and this one just happens to be double that. Okay, so what's A equal to? I'm going with that. I figured the 10.6 you gave me was the final answer, right?
Yeah. Oh, but I got a squared is like 112.8.
Oh, okay. See, now I don't even know what the
I
answer
got
is.
104.37.
Yeah, so then I ran it to 4.
Oh, wait.
Yeah. I got 104.3.
All right, well, so let's figure out how we're going to deal with this, because this, I assume, was exactly 83.2?
I don't know.
No? Oh.
Yeah, it was.
Was? Exactly 83.2? Okay, what's this exactly equal to?
104.37.
Okay, so, big math lesson number 2 for the day, maybe, or 3, I don't know, I'm not counting. You will round only your final answer. You will never, ever round intermediate answers. Intermediate answers are the numbers you get while you're working out your calculation, okay? Yeah?
What if it's like really long?
And you write down fairly long numbers. Okay, so here's what you can do. The question was, what if it's fairly long, right? Like, what if it's 102.768134.9, blah, 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 right? Then you can write down 102.867, dot, dot, dot. Just show me that there's more there, right? So I don't need necessarily see, I don't need you writing out eight decimals and actually, but you will carry those 8 decimals in your calculator, okay? Which means that you will probably need some training on how to use the calculator to do that, and that will follow as we do some of this stuff, okay? Then I'll show you, okay, yeah, this is how you, without writing down the 8 decimals and then typing them all in again, I'll show you this is how you bring numbers down and stuff like that. So we will get to that. But for now, we're going to keep things exact. Okay, and there's only 2 decimals, so I think we can write them up. Okay, so A as an exact value is the root of 104.37. So that's our exact value, from which we then state the rounded answer, which is 10.6. What?
10.2. I'm just saying what this is.
Now it's rounded to the nearest 10, so it's 10.6. I don't really trust you guys with this. 10.2. What is it?
10.2.
Oh, wow. Okay. Wrong brush. It's amazing it worked. All right, 10 inches. Don't tell your parents we're recording it. They don't need to watch this, like a disaster lesson. Okay, are we good? All right, what's left? What did Lancelot say to the beautiful Ellen? To answer the question, you've seen these before, right? You had to it, right? Your teachers could not resist giving them, I'm sure. And neither can we, but you're not going to see a lot of these, okay? There aren't a lot of these and you won't see them in 30 for sure. Okay, 20, you won't see them in 20 either, but you might see a few in 10C. So you've seen this before. To answer the question, so read the instructions, right? Cross out the box containing the answer to each problem. When you finish, write the letters to the boxes that are not crossed out in the boxes at the bottom of the page, in order, left to right, top to bottom. Okay? For each right triangle, find the length of the side that is not given. Now, you know, find it. I don't know, what is it, lost? I could say determine or state. There's not a lot of room to show work here, right? So, you know, what do? Well, if you're doing this for real, then you start on a blank sheet of paper, okay, and you write down the first one, which is A, and you maybe copy the diagram down because it's not going to kill you. And you can label that x, and you can go x squared plus, oh wait, sorry, you can go 10 squared plus 6 squared is equal to x squared. At which point you flip sides around because unknowns are always better on the left side. So x squared is 136. The next thing we're going to write is? Nope. Square root of 136, which actually they give answers in that form at the bottom, right? You save some trouble, right? I don't need to give the decimals because, but then they also give them as decimals, which is, what's it work out to? 11.7? 11.7 what? Meters. It's also actually root 136 meters. So wherever I'm stopping, if I'm stopping at root 136, I'm not going to go any further than that. I will write the meters after the root 136. If I'm then going to go and give the answer nearest tenth, because they also do that, then I'll write the meters after that. So we write them once, we write them at the end. Okay? We only round our final answer, never any intermediate answers, and so right. So that's the work that you would show. Okay. You might be able to kind of squeeze stuff in on there. The answer key that I have here, answers are kind of just sort of squeezed in on there. I'll leave that to you to figure out for yourself, right? If you figure, you're not kidding about it, it's fairly simple Pythagorean Theorem stuff. I can just sort of do it and write my answers down. Because who's checking it?
Nobody.
Right. Well, not me, and that's all I really care about. I ain't looking at it. Okay? You might check answers with friends, right? What'd you get for A? Like, I don't even find an answer, especially in the case of I don't find an answer down here, then you're going to ask somebody else. Hey, what'd you get for, like, D? Because I don't have an answer here. I don't see one of the answers down there. That's when you're going to tell, oh, you asked me too, right? I mean, I'll come over and take a look at stuff. Right? I don't have a problem doing that. Okay, but if you are showing work, then this is what you're going to show, right? So enough work, detail, right? I know this is tough, right? Because how much work did you have to show in grade 9? You have to show a lot of work, or do you just sort of get away with it? You have to show everything? Good. Call your teacher and say, hey, my new math teacher said, good. We're making us show everything, right? Because those of you that don't, you're going to run into problems, okay? So start getting used to the fact that math requires paper and pencil and eraser. Pencil, by the way, do not use pens, okay? Don't want to see any pens. Use a pencil and eraser. Mechanical pencils are great, right? You don't have to sharpen them, but if you do need to sharpen, there's a sharpener somewhere in this room. Usually it resides up here. It's just not here now, but I'll stick it somewhere. So somewhere at the front or at the back maybe, whatever. There'll be a pencil sharpener in the room that you can use if you plan on using wooden type pencils. Mechanical pencils are great. And erasers, it's handy to have an eraser. And show your work, keep it organized, make it so that somebody else can follow it. Write your work as if somebody else is going to read it, because eventually somebody else is. And that's me. Okay, so if you're just kind of sloppily writing stuff down, right, how you practice is how you play. You ever hear that expression? Yeah? Okay, so when you go out, you're going out for the football team. If you're out there practicing, you know, just sort of walking through, going through the motions, your coach is going to tell you. This is how you practice. In the real game, it's how you play, because it's all you know. You haven't practiced properly. So when you do math, do it all out. Do it full. Show the work, so that when game time comes, i.e. test, that's game day, then you will play the way that you practice, which is you'll be used to showing all work, rounding to the nearest tenth, writing full answers, okay, putting on units, showing work, all the good stuff, right? And it means you'll get the marks that go with that. Or you'll only lose